Hey fellow YouTubers, this is N0AGI. I'm here to do a very short video on my NIXIE tube tester project. There's two parts to this as of now. The first part here on your left hand side, that's the timer 555 timer circuit that puts out a clock every so often, and then you can control that using this pot. And then that clock and this LED is just an indicator for that clock tick, and the output of the clock goes into this chip. This chip is called the SN74LS93. It's a 4-bit binary counter that counts the number of clock ticks that comes in. So if you look at the layout, there's tons of data sheets and YouTube videos out there. But just quickly, this chip here has 14 pins. What we really care about is this pin number 14 up here, and that pin takes the input from the clock tick source. It could be this 555 timer's output, or it could be a frequency generator that you might have handy, whichever works. Of course, in my case, I'm trying to make this as decoupled and independent as possible, so I built this clock circuit using 555 timer, and it takes an input and then it starts counting, and then and the output of the count is produced as a 4-bit binary value. So for example, this is lowest order bit and this is the high order bit, so there are 4 bits. For example, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so forth. The 4 bits here count up to 15 digits. Of course, in my case, for the purpose of the NIXIE tube testing project, all I really care about is up to 9 digits. So you could set it up. You can configure this chip so that it only counts up to 9 and then it resets itself, and it's fairly straightforward to do that. Before I go on to describing further, just quickly, the output pins from this chip are hooked up to these LEDs through a 220 ohm resistors here, and then they are simply connected up through this breadboard into these LEDs. And the other pin here is pin number, I believe that's the pin number, let's see, 1, 2, 5. Pin number 5 is hooked up to the VCC in. Okay, so that's this guy here, that's hooked up to VCC. So these 2 pins here, well, actually the 3 pins here that you should care about. The pin number 1, 2, and 3. Pin number 1 takes the clock counter input. So for example, the least common denominator here is 1. What I've done is I connected up that this is called the pin A, or the they call it QA. Hook that up to the pin number 1 through a simple jumper wire. And pin 2 and 3, they're called reset pins. This is a reset pin 0 and reset pin 1. What they do is you can configure those 2 pins such that you can determine when the counter should reset itself. These 2 pins, they work as a in an AND operator, so that if pin 0 or reset 0 and reset 1 are both high, then it would reset. Okay, it would reset the counter. So just as an example, right now I have enabled the default behavior. The default behavior is really to take the pin number 2 and ground it. Okay, what that does is basically just discards any resetting. It does the default up to 15 counting. So you could enable the default behavior by simply taking pin number 2 and then grounding that, and that basically allows the counter to go up to 15. Okay, but in my case, however, I want the pin to reset when it reaches or when it goes past 9. What I mean by that is I want the bit 4, which is 8, and bit 1 to be on, and when they're both on, the value is 9. But I don't want to reset at 9. I want to reset at 10. So what I mean by that is I want to reset when bit 4 and bit 2 are both high. When they're both high, it tells me that the value 10 has reached, and I want to reset this pin when the value 10 has reached. So what I want to do is basically take this pin here, take the pin R2, or rather R0 pin, hook that up to pin or the bit 4, okay, and when bit 4 is enabled, when the bit 4 is high, it would reset it. But I don't want it to reset just by bit 4. I also want to reset only if bit 4 and bit 1 are both high, right? Now, what I've done is I'm basically, again, just to reiterate, when bit 4 and bit 2 are both high, that's the number 10, and I want to reset the chip when it reaches number 10. I want to count up to 9, but not beyond 9 is my point. Okay. So now let's count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, reset. Right? So that seems to work pretty good. So it's fairly straightforward. I'm only supplying 5 volts right now from my benchtop power supply, and it's putting out approximately a second pulse. I can make it go faster, and it counts faster because the clocks are coming in faster. Let's go even faster. Okay, so that proves a point. So as my next step, my goal is to then, instead of taking these for binary values as is, what I want to do is I want to feed these 4 binary bits into the chip that will drive my NIXIE tubes. In my previous video, I had shown you a bunch of these. I got these on eBay from a Ukraine seller, and these are the K155 ID1, I believe that's how that is. K155 ID1 chip. These chips are binary to decimal driver chips, specifically made for. These are specifically made for driving NIXIE tubes. So I'm going to hook one of these up. These guys take those 4 bits, right, as input, and then it produces 9 outputs that we would then connect up to the NIXIE tube. Okay, so that's my next step. For now, I think this is a pretty good milestone for me. I'm gonna start working on my next step here, basically hooking up that K155 ID1 and my NIXIE tube. Thanks for watching.